Hello everyone, today I'm glad to talk about the application of derivatives and the explanation of concepts. So, derivatives are widely applied in economies to analyze rates of change and optimize various functions. Here's how derivatives are used in context of cost, revenue, and profit functions, along with 3 detailed examples. First one is cost function and average cost function. Cost function (CQ) represents the total cost of producing Q units of product. Marginal cost (MC) equals to dCQ over dQ. It measures the additional cost of producing one more unit. And here we also have average cost AC equals to CQ over Q, which represents the average cost per unit of production. The role of derivatives in this concept is identify the level of output that minimizes average cost by differentiating AC and setting the derivative to 0, and also analyze the relationship between marginal cost and average cost. So here's an example 1 to explain the cost function and average cost function. Suppose the total cost function is CQ equals to 50 plus 10Q plus 2Q squared. It requires us to find the first one is marginal cost, which is MC, and second, the output level that minimizes average cost AC. So here's how we solve this one. First, we find MC equals to dCQ over dQ, which equals to 10 plus 4Q, and then it's shown that AC equals to CQ over Q, which equals to 50 over Q plus 10 plus 2Q. And then we differentiate AC to this, and let's set the dAC over dQ equals to 0, which is when the average cost hit the minimum. So when dAC over dQ equals to 0, we can find that Q equals to 5. Thus, the average cost is minimized at Q equals to 5. Then let me explain the revenue function and average revenue function. So about revenue function RQ, it represents the total revenue from selling Q units of product. Second is marginal revenue. MR equals to DRQ over DQ, which measures the additional revenue generated by selling one more unit. And next, what we have is average revenue. AR equals to RQ over Q, which represents the revenue per unit sold. So, in this part, the role of derivatives is to analyze how revenue changes as sales increased and identify the point of diminishing returns where MR starts decreasing. So here we also have an example here. Suppose the revenue function is RQ equals to 100Q plus negative 3Q. It asks us to find the marginal revenue, which is MR, and the output level that maximizes total revenue. So here's the solution. We can get that MR equals to DRQ over DQ, which equals to 100 plus negative 6Q. And then to maximize total revenue, we set MR equals to 0. And then we get, when MR equals to 0, we can get that Q equals to 100 over 6, which is 16.67. Thus, total revenue is maximized at approximately Q equals to 16 and 0.67. So let's go into the next part. We are going to explain the profit function and average profit function. So first, the profit function represents the total profit from this of. Then let's look at the profit function and average profit function. So profit function represents the total profit from selling Q units of a product, and marginal profit of it measures the additional profit from selling one more unit. Then we have average profit here also, which represents the profit per unit sold. And in this part, the role of derivatives is to determine the output level that maximizes profit and also analyze how profit changes with respect to output. Here we also have an example problem for it. So let's suppose the cost of function is CQ equals to 50 plus 10Q plus Q squared, and the revenue function is RQ equals to 120Q plus negative 2Q squared. It requires us to find the profit maximizing output level and the maximum profit. So the profit function is shown here, and we have to differentiate it, which we can get 110 equals plus 6Q, and let's set MP equals to 0, which is when the profit hit the maximum. So when MP equals to 0, we can get that Q equals to 110 over 6, which is 18.33. Thus, the profit maximized at Q equals to 18.33. So here, maximum profit. To get maximum profit, we substitute Q equals to 18.33 into pi q, and we can get 1016.67. Thus, the maximum profit is approximately 1016.67. And then let's make a summary of the applications about derivative. So summary of applications: cost analysis. Marginal and average cost help firms minimize production costs. Revenue analysis. Marginal revenue assists in identifying optimal sales levels. And also profit maximization. Firms use marginal profit to determine the most profitable output level. And after that, we are going to explain the washer method and how we can use washer method to solve the problems. So let's go and see this example problem here. It asks us to find the volume of solid obtained by revolving the region bounded by y equals to x squared and y equals to 4 and x equals to 0 about the x-axis. So first we have to find the outer and inner radius. The outer radius is Rx equals to 4 and inner radius is Rx equals to x squared. And then we use the volume formula here. Using the washer method, we have to use the formula, which is pi integral a to b Rx squared plus negative Rx squared dx. So the third step we are going to deal with is the bounds and setup. So we can see that in the region is bounded from x equals to 0 to x equals to 2, since y equals to 4 intersects y equals to x squared at x equals to 2. So the volume will be equals to pi integral 0 to 2 and 4 squared plus negative x squared dx. After simplify, we can get this function in the fourth part. And the last step we are going to do is to integrate. So after calculate, we can get that the final volume is 128 pi over 5. So this is how we use the washer method to solve problem like this, which asks us to find the volume of solid. So next, I am going to explain the moments and center of mass. So moments and center of mass are fundamental concepts in calculus, physics, and engineering often used to analyze how mass or area is distributed in a system. A moment measures the tendency of physical quantity, such as mass or force, to cause rotation about a point or axis. It essentially weighs the position of mass or area by its distance from reference point. So to explain moment of a point mass. For a point mass m located at distance x for a reference point, the method is upper M equals to m plus x. For a continuous mass distribution along a line, the moment about a point is upper M equals to integral x dm. Then we are going to explain the center of mass here. The center of mass is average position of all the mass in system, weighted by the distribution of that mass. It represents the balance point, where the total mass could be concentrated without affecting the overall behavior of the system. So for a discrete system of mass m1, m2 until mn located in a position x1, x2 until xn, the center of mass x is given by this function. And also for a continuous mass distribution, the center of mass is here. So they are different. So we also have an example to explain the center of mass problems here. Consider 2-point masses m1 equals to 2 located at x1 equals to 3 and m2 equals to 3 located at x2 equals to 5. The moment about y-axis my equals to m1 x1 plus m2 x2, which is 2 plus 3, 2 with 3 plus 3, 5, so we can get 21. And the total mass m equals to m1 plus m2, which is 5. So in the end, we can get that the center of mass here is 4.2. So that's all we are going to talk about, the application and derivatives and the explanation of concepts today. So thanks for your attention on listening and watching.